The level of taurine in the bodies of mice, monkeys, and men and women declines with age, dropping by nearly 80% over the lifespan. This is due, in rats at least, to a decline in the synthesis of taurine. Would there be any benefit to restoring youthful levels through taurine supplementation? After all, lower taurine levels have been associated with all sorts of disease conditions of the bone, blood, eyes, heart, cancer. Of course, just because there's a correlation between lower levels and disease doesn't necessarily mean that lower levels cause disease. It could be the other way around, where, for example, disease leads to lower taurine levels. In my last video, I talked about how taurine is an antioxidant in the context of inflammation, so in the context of disease, more taurine may just get used up. The only way to know if taurine may help is to put it to the test. We know blood concentrations of taurine declines with age, so to investigate whether this decline contributes to aging, researchers fed taurine, or not, to middle-aged mice until the end of their life, and taurine-fed mice lived longer, significantly longer, like the human equivalent of 7 to 8 years longer, and they had only started the taurine later in life in middle age. Now, a meaningful anti-aging therapy should not only improve lifespan, but also health span, the period of healthy living. So researchers then investigated the health of the taurine-fed middle-aged mice and found, compared to the control group, improved functioning of bone, muscle, pancreas, brain, fat, gut, and immune system, indicating an overall increase in health span as well as lifespan. They also tried it on other species. Taurine didn't make yeast live longer, but it did increase the lifespan of microscopic worms, 10% or more increased average lifespan in middle-aged worms and mice. And the mice didn't just live longer, but also healthier, with improvements in strength, coordination, and memory, as well as attenuation of multiple hallmarks of aging, such as cellular senescence, DNA damage, chronic inflammation, many of the aging pathways I talked about in my longevity book, How Not to Age. And in middle-aged rhesus macaque monkeys, 6 months of taurine supplementation led to positive effects on bone health, metabolism, and apparent immune health. There were similar health effects in monkeys who were in the middle-age equivalent of a human about 45 to 50 years old, but that's still 15 years for a monkey, which is why it's so hard to do longevity experiments on monkeys. If you're a microscopic worm, middle age is just 2 weeks, so it's a lot easier. But researchers did find that even just 6 months of extra taurine had beneficial effects on most tested health parameters in middle-aged monkeys, including 1 or 2 fewer pounds of weight gain, better bone mineral density, better blood sugars, and lower measures of inflammation and oxidation. If you take people and have them exercise, at least in active individuals, exercise increases the concentration of taurine in the blood, so that might even partially explain the anti-aging effects of exercise. The bottom line is that taurine supplementation makes animals live longer, but what that means for people is unclear. This is not the first time benefits of taurine supplementation have been demonstrated in lab animals, reducing blood pressure in rats, or reducing atherosclerosis in the coronary arteries of rabbits fed cholesterol. But the extrapolation of findings from animal studies is difficult due to the problems not only with dosing, but the biological differences between species. For example, the final step in taurine synthesis in rodents involves a completely different enzyme than in people, and is actually much more efficient in them than in us. But maybe it needs to be so much more efficient because the normal levels in the blood and brains of rodents may be as much as 10 times higher, potentially making them more susceptible to problems with slipping levels as they age. Unfortunately, little is known about the effects of taurine supplementation in humans. Here's a graphical illustration of the study. Taurine levels decrease with age, and taurine supplementation to reverse this trend can increase the lifespan of animals by countering the many drivers of aging and boosting health in the process. In people, lower taurine levels correlate with worse health, but the missing piece, a randomized clinical trial of taurine in people. What should we do while we wait? Correction of late-life taurine declines in humans could be beneficial for cognitive performance, energy metabolism, sexual function, and vision, but clinical studies remain to be performed. There have been some short-term randomized controlled trials of taurine supplementation in people, and I'll run through what they found next.